Okay, Assalamualaikum and good evening once again, Aisha and Prabha. In the last lecture, we started with amines and we were around the chemical properties of amines, right? Chemical properties of amines. Yeah. So we have done two reactions. Let's start with the third one. Write the reaction basic character. Now, in basic character of amines, first of all, why it acts as a base? Then it acts as a base because of the lone pair electron on the nitrogen atom of amines. So when you add RNH2 inside water, the lone pair electron, it attacks on the H plus ion, not H plus ion, but rather the hydrogen, which is having a partial positive charge, which is attached to a more electronegative oxygen atom like this, right, in water. So this oxygen is pulling electron density. That is why this hydrogen is having delta positive, and this lone pair attacks here, and the nitrogen gets protonated, and you get RNH3 with a positive charge on nitrogen atom. Plus you get OH negative. That means we can say what happens when we add amines in water, we get OH negative ions, right? So NH2, it is not releasing OH negative ions, but rather it is, even though it is not releasing, but it is increasing the concentration of OH negative ion. That is why we say that amines are what? Amines are basic in nature. So you'll write amines abstract hydrogen from H2O due to the presence of lone pair electrons on nitrogen atom. On nitrogen atom. Therefore, amines are Lewis base. So the species which can donate electron pair, they are known as Lewis base. And in order to know the basic character and in order to know the basic strength, we should write the equilibrium constant for this reaction, which will be RNH3 positive, the concentration of protonated amine, and OH negative divided by the reactant, that is amines and water. And since the concentration of water will be a constant as it is a pure liquid, you can ignore it and we will get the Kb, that will be equal to RNH3 positive multiplied with OH negative divided by the concentration of amines. Now, another thing is that if we have a strong base will have higher concentration of OH negative, and consecutively what is going to happen, this Kb will also increase. So a strong base will have higher value of Kb. Strong base has higher value of Kb, but the Kb values, they are generally in terms of powers of 10, and it is not very logical, or I would say it is not very human tendency to grasp very large number. For example, when people generally say that what is the difference between 1 million and 1 billion, so they say it seems like it's not a very huge difference between 1 million and 1 billion, है ना? 6 zeros and 8 zeros, बस 3 zero तो बढ़ रहे हैं, क्या ही change हो जाएगा? But actually it is very large difference. Like for example, if you take into consideration like how much is 1 million second and 1 billion seconds, so that is actually a very huge difference, huh? So when you take those seconds, So that since we cannot comprehend a very large number, that is why we translate, or we rather convert this into pkb. And pkb, it means the power of kb. Power means minus log of kb. P means minus log of kb. So for a strong base, kb is high, and since kb is high, the log of kb will also be high. And since log of kb is high, then the negative log of kb, this will be lower, है ना? Because if I compare 7, 8, so obviously 8 is greater. But if I compare -7 and -8, then -7 is greater. है ना? So minus log kb will be what? Low if the kb is high. And if minus log kb is low, that means it is nothing but pkb. So pkb will also be low. And that is why I will say that strong base has lower value of pkb. This is more important because generally आपको जो सवाल होगा ना वो pkb के relative होगा, ठीक है ना? Even though kb is very intuitive to understand, pkb में relation negative वाला होता है. That is why strong base will have lower value of pkb. Now moving on to the different amines and the strengths. So if I talk about amines से पहले we can talk about ammonia also, that is having 3 hydrogen that is attached with nitrogen atom. Then we have 1 degree amine in which one alkyl group it is attached with 2 hydrogens. Then we can have, एक काम करते हैं, like you will write here NH3, but in order to understand, I'm writing here CH3 because I need to explain you something. Okay, so this is alkyl group. Write RNH, nitrogen connected with 2 hydrogen. We have another case in which 2 alkyl groups are attached with. Sorry. What are you saying?
Your voice is cracking.
My voice is cracking for everyone?
Yes, sir.
Yes. Okay. How is it now? Is it better?
Yes, sir, better.
Okay, so I'm saying that you will write this as R only, you will not write the methyl group. I just want to explain something, that's why I'm writing this methyl group, and you can see I'm writing the full methyl group also. Right? So here we have the second, the 2 degree, and then we can have 3 degree, in which the nitrogen atom is connected with 3 alkyl groups. There is no hydrogen here. Now, we have to understand like where the basic nature is coming from. So basic nature is coming from the electron density, right? So this nitrogen, it has electron pair, this nitrogen has an electron pair, this nitrogen has an electron pair, and this nitrogen is also having an electron pair. Now, when you have a alkyl group attached to nitrogen atom, it would increase the electron density, right? Because it is a electron donating group. And we would expect it to increase the electron density. And if the nitrogen is having a higher electron density, it would be easier for nitrogen to lose that electron pair. And because nitrogen ke paas already the alkyl groups are pushing the electrons. So if I consider the electronic effect that is due to the plus I group, then we would say that 3 degree will be most acidic, followed by 2 degree, followed by 1 degree, and then followed by ammonia, NH3. Okay, this is the basicity. Basic character हम लोग बात करें, this is the basicity. The basic strength we are talking about, right? Talking about the basic strength of different types of ammonia. Now there is another thing that we have to consider. In order to, please try to understand here, please don't write if you're writing. In order to attack on hydrogen atom, this nitrogen, this whole ammonia has to move and then attack on the hydrogen which is having electron deficiency. Similarly, this group, this whole molecule has to move and attack the nitrogen atom. Here, this whole molecule has to move and attack the nitrogen atom. And here, this whole molecule has to move and attack the hydrogen atom in order to show the basic nature. So the lone pair should reach the hydrogen atom. If it is not reaching the hydrogen atom, it won't show basic nature. Fine. Now you guys tell me, look at the size of things and tell me kiska movement आसान होगा, which will be having the easiest movement. Here we have this is ammonia. This is 1 degree, this is 2 degree, and this is 3 degree. Tell me about the movement. Like, look at the structure, look at the size, and tell me किसका movement सबसे आसान होगा?
Ammonia.
Ammonia 1 degree. Which one, Mariam?
Ammonia.
Ammonia का movement सबसे आसान होगा, right? So if I look, now this is known as sterics, like the chemistry which is revolving around bulky groups, right? I hope all of you understand that, because 1 degree, 2 degree, and 3 degree, 3 degree the most, 3 degree is having the most number of bulky groups. That is why the movement is having some kind of barrier. It is restricted. So this chemistry that revolves around the bulky group of different chemical species, we call it steric effect. So एक तो electronic effect है, and the other thing is steric effect. And in steric effect, if we see, then we can say that if I only look at steric effect, then ammonia's movement should be faster and it would reach the hydrogen easily. And that is why it will act as a stronger base. Ammonia followed by 1 degree, then followed by 2 degree, and then followed by 3 degree. So this is the basicity if we consider the steric effect. Now you can easily see that both of these effects are giving me contradictory results. मेक सेंस है? सुनो, इलेक्ट्रॉनिक में 3 डिग्री सबसे ज्यादा बेसिक हो रहा है और स्टेरिक में 3 डिग्री सबसे कम बेसिक हो रहा है. दैट इज व्हाई वी हैव टू बेस आवर कंक्लूजन ऑन द एक्सपेरिमेंटल डेटा. ठीक है, तो अब इसमें जो एक्सपेरिमेंट से डेटा आया है, डेटा को हम क्या करते हैं, आई मीन देयर इज नो डायरेक्ट रिलेशनशिप बिटवीन द स्ट्रक्चर एंड द बेसिक नेचर. जैसा कि हमारे पास पहले के चैप्टर्स में एसिडिक कैरेक्टर में हो रहा था. सो यू विल राइट हियर अ लाइन, सिंस बेसिसिटी is determined by multiple factors with conflicting results, we will conclude according to experimental data. And the experimental data, we have to study only about two different groups, that is ethyl group and methyl group. तो सबसे पहले हम लोग बात करेंगे if we have a ethyl substituent on the amine. Ethyl substituent. When we talk about ethyl substituent, then 2 degree is most basic, followed by 3 degree, followed by 1 degree, and then followed by NH3. If I talk about the structure, ethyl is C2H5, 2 degree सबसे ज़्यादा. There are 2 C2H5 and nitrogen has 1 hydrogen. This is the most basic, followed by C2H5. 3 degree will be having 3 C2H5s bonded to 1 nitrogen atom. And then you will have C2H5, which is bonded to 1 nitrogen, and there are 2 hydrogens. And then you have ammonia, that is NH3. So this is the order for ethyl. Then we have methyl substituent. Now in methyl substituent, there is a slight change. 2 degrees is still the most basic. 2 degree, followed by 1 degree, then followed by 3 degree, and then followed by ammonia. If I want to write the structures, then it will be CH3. Let me make it once again. CH3 whole twice NH, followed by CH3, followed by CH3 NH2, followed by CH3 whole thrice nitrogen, and then which is followed by ammonia NH3. Okay. Now there is one thing that we can say for sure. It is 2 degree amine is most basic, And another concluding point we can write is amines are more basic than ammonia due to plus I effect of alkyl groups. Okay. So these 2 points we can conclude. Write this down. Then we will look at aniline versus amine. Please raise your hand once you're done writing. Waiting for Aisha and Rabah. Moving on, please write. Aniline versus amine versus amine. So if you look at aniline, aniline will have a benzene ring that is attached with nitrogen atom and 2 hydrogens with a lone pair on nitrogen atom. This nitrogen atom would show resonance like this. And you can easily see that the electron pair that was responsible for the basic nature, it is involved in resonance. Now, if it is involved in resonance, वो busy हो गया है. It is delocalized. It is not in one place. And if it is showing resonance, that means this electron pair is no longer available for. It is no longer available for what? Available for the donation of electron. Available to show the basic nature. That is why these are not as basic as that, as ammonia also. Amines की तो बात दूर है. They are not even basic for. They are not as basic as ammonia. So you'll write aryl amines basically aniline. आप लोगों को ज्यादा पढ़ना है. Are less basic because the lone pair electron on nitrogen atom is delocalized due to resonance and not available to attack on hydrogen. ठीक, right? Therefore, arylamines are even than ammonia. Am I audible, guys?
Yes, sir.
So we have got a kind of conclusion that amines are the most basic, or amines में भी 2 degree सबसे ज्यादा है ना? And then you have ammonia, and then you have aniline. Now, regarding aniline, we can also write one more point, that basicity of aniline directly proportional to electron donating group, and it is inversely proportional to electron withdrawing groups. Electron donating groups such as CH3, OCH3, ठीक है, etc. Electron withdrawing groups such as NO2, CHO, COCH3, these type of things. You write this question. फर्स्ट ऑफ ऑल आप इसको क्लासिफाई कीजिएगा, अमीन है, एनिलीन है, या फिर अमोनिया है, ठीक है? और अगर अमीन है तो व्हाट इज द डिग्री ऑफ दैट अमीन? अच्छा, लेट मी डू दिस फॉर यू, एक पे दूसरा सवाल आप लोग कर लीजिएगा, लेट मी डू दिस फॉर यू, ठीक है? देखिए यहाँ पे C6H5NH2, आई होप ऑल ऑफ यू कैन आइडेंटिफाई दिस इज एनिलीन. C2H5NH2, this is 1 degree. C2H5 voltwise NH, this is 2 degree. And NH3, this is ammonia. That's it. And we have the order कि सबसे ज्यादा 2 degree होता है. That is why if I number this A, B, C, and D, then the most basic is going to be 2 degree, that is C, followed by amine, still amine, then 1 degree, that is B. Then you will have ammonia, that is D, and then you will have aniline, that is E. ठीक है? So अमीन में 2 डिग्री से ज्यादा, और उसके बाद के बाद अमीन बाद में आएंगे, अमोनिया आएगा, उसके बाद फिर एनिलीन आएगा, ठीक है? सो इट्स वेरी कंसिस्टेंट टू व्हाट वी हैव स्टडीड टिल नाउ. इसका दूसरा आपको कीजिए जरा, पीकेबी बोला हुआ है इसमें, तो आप लोग घबराइएगा मत, पीकेबी ऐसा कुछ हार्ड चीज नहीं है. इट्स जस्ट दैट जो एसिडिक नेचर का, जो आपको सबसे ज्यादा एसिडिक मिलेगा उसका उल्टा कर दीजिएगा, तो आपको पीकेबी मिल जाएगा फिर वहां से, है ना? यू हैव टू डू द सेम थिंग जो कि हम लोगों ने यहाँ पे किया था. ट्राई टू डू द सेम थिंग. You can send me the answer. The ऐसे ऑप्शन कर दीजिएगा A, B, C and D. So you can send the answer on Zoom as well as on the WhatsApp. जैसी मर्जी आपकी. I've got one answer. Okay, Parker. Actually, I will give you guys 1 more minute. It's fine. So Parker has changed the answer. Actually, ठीक है देखते हैं. So the first one is obviously it is 1 degree amine, C6H5NHCH3. So it is aniline plus a CH3 group is there. So that is an electron donating group. We have to consider that also. C2H5 is 2 degree amine, and then D is pure aniline. Now, if I talk about the acidic strength, then the most acidic will be the C structure, which is 2 degree, most acidic, right? Then after that, you'll have the 1 degree, most acidic is 1 degree. Then you will have the B1, the C के बाद हमने A लिखना था. Then you will have the B1 because it is aniline, plus we are having an electron donating group, that is CH3 group. And at last we have the pure simple aniline, that will be the small, the least acidic. So the most acidic, the least acidic. So if I want to write the pKb, अच्छा वैसे इन्होंने क्या decreasing order of pKb, decreasing खैर इसको increasing order हो जाएगा ऐसे. अच्छा decreasing order of the pKb will be the same thing. खैर ठीक है. So pKb का अगर हम order लिखें यहाँ पे तो you will write the same thing C A B D and just do this. आपको बोला हुआ है डिक्रीजिंग ऑर्डर, तो डिक्रीजिंग ऑर्डर क्या हो जाएगा इसका? डिक्रीजिंग ऑर्डर हो जाएगा डी बी ए सी. सही हुआ. ए सी बी डी कैसे हो जा रहा है? ए बी सी डी. आयशा, ए बी सी डी भी सही नहीं है. सबसे ज्यादा ए का, दैट मींस दैट इज द लीस्ट बेसिक. हाउ इट इज लीस्ट बेसिक? भाई जो सिंपल आइडिया है ना, द सिंपल आइडिया इज 2 डिग्री सबसे ज्यादा, उसके बाद बाकी सारे अमीन, चाहे वो बाकी सारे अमीन, उसके बाद अमोनिया, उसके बाद एनीन. सबसे ज्यादा बेसिक तो आपके पास क्या होगा? 2 डिग्री होगा, उसके बाद फिर ये आ जाएगा. मेक सेंस? सुनो पार्कर, आयशा, वेल
Yes,
आंसर्ड.
sir.
ठीक है, प्लीज कॉपी दिस डाउन. After this, you'll write acylation. This is the fourth reaction. Now, in acylation, we will take an example of our NH2 plus R dash C double bond O Cl. We are taking a acyl chloride. This is Cl. We're taking a acyl chloride, but this reaction can be done with anhydride and esters also. The mechanism is going to be the same. This carbonyl carbon, it is delta positive because it is attached with oxygen and also a chlorine atom. This nitrogen atom will attack the carbonyl like this, and you will see something like this happening. R dash as it is, which is bonded to carbon, single bond with oxygen, because as soon as this nitrogen attacks and makes a bond with carbon, the carbon will say that I already have 4 bonds, so it will break the pi bond, making this O negative. Now this will get O negative, and here you will have nitrogen, which is having 2 hydrogens and 1 alkyl group. Alkyl group, 1 hydrogen, another hydrogen. This carbon atom is having chlorine like this. This carbon atom is having chlorine. Now this nitrogen atom will be having a positive charge because it is having 4 bonds now. And this hydrogen atom, which is connected with nitrogen, it will be having a highly delta positive charge because it is connected with electronegative element as well as a positive charge. It will be having highly delta positive charge. And the chlorine atom with all of its lone pair electrons sees a chance that it can attack the hydrogen, which is connected with nitrogen atom. So a sequence of reaction take place. This chlorine, it makes a bond with hydrogen. As soon as hydrogen sees that, okay, fine, it is getting electron pair from chlorine, it gives the electron pair to the nitrogen atom and it neutralizes the nitrogen atom. As soon as carbon sees that, okay, fine, the chlorine bond is breaking because chlorine can form only one bond and it is forming a bond with hydrogen atom. This minus charge, it gets to pi bond once again and you get something like this. देखिए HCl तो यहाँ से निकल जाएगा. So we'll remove the HCl from here. And what you are getting is R dash, which is having a C double bond O. This is connected with a nitrogen atom. This nitrogen atom is neutralized, so there is no charge. And it has 1 hydrogen atom here, as you can see. It has an H, and it is followed by a alkyl group like this. Okay. So this is what? This is amide. You can write aromatic and aliphatic. And aliphatic amines. Now, there is a caveat that since we are talking about amines, not all amines will react like this because this chlorine atom needs to get a hydrogen. And hydrogen is only available in 1 degree and 2 degree amines. 3 degree amine does not have any hydrogen atoms. That is why amines, and I write 1 degree and 2 degree. Okay. Reacts with acid chloride, acid anhydride, and esters to form amide. Now, I will give the reactions for all of these with an example also. So let us suppose we have amine that is CH3NH2. It's a 1 degree amine. If I react this with, let us suppose you have 2 carbon atoms and C double bond O Cl, then the product that you are going to get is, see, this whole thing will be as it is. This whole thing will be as it is. You need to attach, you need to remove the hydrogen from amine and chlorine from the acid chloride. आपको क्या मिलेगा? This whole thing will be as it is. इसको as it is लिखिए बिल्कुल. Double bond O, and you will attach this with nitrogen, which is having 1 hydrogen and then CH3. Similarly, if you have, let's suppose 2 carbon atoms, double bond O, oxygen with double bond O, and then CH3 like this, then what's going to happen? This whole thing will be as it is. It will be bonded with NH, further bonded with CH3. And similar thing will happen if you have esters also. That is 2 carbon atoms, double bond, rather I'm writing 3 carbon atoms, right? Yeah, 3 carbon atoms, double bond O, and then you have OCH3. So the carbonyl carbon fragment is intact. It is bonded with NH, CH3 that is coming from the amine. Okay. Now, if you want to write the name of these compounds, see all of these are having same structures because I have taken similar fragments. So all of this, they have the functional group that is amide. And if we talk about unsaturation, there is no carbon-carbon double bond. There you have only single bonds, so it will be AN. The parent carbon will be the longest carbon chain in which you have the amide group. So this carbon atom, see this 1 carbon, 2 carbon, and 3 carbon. So there it is, prop, starting from the carbonyl carbon. And if you look at the substituent, then you might say, fine, this NH is also a part of substituent, but not, because see this whole thing is a part of functional group, and this whole thing is part of like the parent carbon chain. Okay, so that is why we have also considered NH while we were writing about the oh, well, we were writing about the functional group and the parent. So with the only substituent left is CH3. So substituent, it is going to be methyl. Now, the problem with methyl is that methyl is attached to which carbon atom? Since it is not attached to carbon atom, it is attached to nitrogen atom. So we will write this as N-methyl. The name of all of these compounds is same, that is N-methyl propane amide. Okay, so this is the name, N-methyl propane amide. Now I need to erase a few things because यहाँ पे फिर दिखेगा नहीं. Please write this down. Raise your hand once you're done. N-methyl propanamide. हाँ ठीक है. Now we have considered almost all the cases of C double bond O, but we have not considered when you have C double bond O and then OH. है ना, हम लोगों ने acid chloride देख लिया, but the main thing, that is the carboxylic acid, we have not seen. So when you react, let us suppose CH3 COOH with CH3NH2. So since this is an acid and it is a base, there will be an acid-base reaction in which the hydrogen of COOH, the acetic acid, will go to nitrogen and you will get CH3 COO negative, and here you will have NH3 positive, which is connected to CH3 like this. So you are basically getting a salt here. Please raise your hand if you are done. Anyone still writing? Aisha, Rabah? Rabah, just waiting for you now. Okay. If you're done. So moving on, please write a reaction with nitrous acid. Nitrous acid is HNO2. I call it ONO because it has the structure of OH bonded to NO. So if you have 1 degree amine, that is RNH2. And you treat this with NaNO2 plus HCl, which actually gives you the HNO2. You are going to get Rn2 positive, Cl negative. This is diazonium salt, diazonium salt, which is quite unstable. As soon as it reacts with moisture, the presence of a bit of heat, it gives ROH, that is alcohol, and it gives you HCl gas. Now, this part that we are having alcohol, we have seen this when we were doing the method of preparation of alcohols. Similar reaction is shown by aniline. Now, this aniline is actually quite stable. We have the same thing, NaNO2 plus HCl. That is also done in a quite lower temperature. This is also done in lower temperature, and you get benzene diazonium salt. You have benzene, and the diazonium salt is like this, N2 positive, Cl negative. Now, this is benzene diazonium chloride, which is quite stable due to resonance. We will learn in detail about the method of preparation of diazonium salts and also its chemical properties. There's a different section in this chapter. इसमें detail देखेंगे. But right now, let us see what would happen if you react this with 2 degree amines. So 2 degree amines will have nitrogen atom that is having 2 alkyl groups and 1 hydrogen atom. When it reacts with ONO, so the ONO has this type of structure, ONO. This thing will combine to make water. And as it would combine, you will get nitrogen, which is connected with 2 alkyl groups. This is further connected with a nitrogen atom. And this is having a double bond with oxygen. This is known as nitrosoamine. Okay, plus you will be getting water. Now, if you have a 3 degree, that is, you have nitrogen atom that is connected with 3 alkyl groups, and you react this with ONO, HNO2, you will be first of all getting a salt that is R thrice NH, and this will be having a positive charge, and NO2 will be having a negative charge. Now, in the presence of a bit of water or something, what would happen? You will get R2 nitrogen, singly bonded with nitrogen, and double bond O. That is again, you are going to get nitrosoamine, but plus here you will also get ROH. Please write this down. These two reactions, by the way, are not there in the NCERT, and I have not seen any question asked in the CBSE also. They have just written 2 degree and 3 degree amines. They react differently with nitrous acid. And since they have just mentioned it, that is why I have written. Yeah. So you need to just like warm it here. Okay. No need of heating or anything. The next reaction is quite important. So please raise your hand if you're done. Waiting for Aisha, Parker, and Rabah. By the way, I think Parker was disconnected for a while. Waiting for Mariam Parker. Right, next reaction with aryl sulfonyl chloride. The sixth reaction. Reaction with aryl sulfonyl chloride. What is aryl sulfonyl chloride? It has a structure like this: benzene ring. It is attached with sulfur atom, which has double bond oxygen, and it has a bond with chlorine. Now, this particular reaction and this particular structure is quite similar as that of acyl chloride also. So you can expect that a similar reaction would take place here also, that the nitrogen will get bonded to the carbonyl carbon in this case, which was having a double bond with oxygen. Here it will be get bonded with the sulfur atom. Since sulfur is what it is attached with double bond O, two double bond O and a chlorine atom, it will be highly electrophilic, will have a highly partial positive charge. Okay. And this particular molecule, it is also known as Hinsberg reagent. Hinsberg reagent. Now, when this Hinsberg reagent, it is reacted with 1 degree or 2 degree or 3 degree amines, it gives different types of product. Okay. So different type of situation, I would say, not also product. So that is why it can be used for distinction of 1 degree, 2 degree, and 3 degree amines. It shows with different types of amines. So please see, we have this benzene sulfonyl chloride. And let us suppose it reacts with 1 degree amine. That is RNH2. So one hydrogen from amine and one chlorine from the sulfonyl chloride will make HCl. There will be a bond between nitrogen and sulfur. So benzene ring is, I'm writing that as PH, which is bonded with sulfur, doubly bonded with oxygen as it is, doubly bonded with oxygen as it is. Now it has a new bond with nitrogen, जिसमें से एक हाइड्रोजन निकल चुका है. So there is one hydrogen remaining and the alkyl group is as it is. ठीक है. Now, if you look at this particular hydrogen atom here, this hydrogen, if you remove this hydrogen, nitrogen is going to get a negative charge. This negative charge will be resonance stabilized with this oxygen atom and further resonance stabilized by the benzene ring. That means we can easily remove this hydrogen and this nitrogen can easily get a negative charge and it can act as a acidic hydrogen. So this hydrogen is basically, it is what it is, acidic hydrogen. It is acidic hydrogen. Now, since it is an acidic hydrogen, it can easily break. And if it can break, that means therefore it is soluble in alkali. If you have a basic solution, that means we can dissolve this in basic solution because it will react with the alkali and it will form it will form a negative charge, and charged molecules, they are generally soluble in alkalis. Okay. So this is the case of 1 degree amine. Because of acidic hydrogen, it is soluble in alkali. Next we have the 2 degree amine. So here you will have a nitrogen atom. It is attached with 3 different groups. 2 of them are alkyl group and 1 of them is hydrogen. So what will happen? The hydrogen and fluorine will leave. You will have PH bonded to sulfur, which is having a double bond O and double bond O. And this is further bonded to nitrogen, which is having an alkyl group, and the other one is also alkyl group because one of the hydrogen has gone away with the chlorine atom. Now we are getting a product, but there is no acidic hydrogen. No acidic hydrogen. Therefore, not soluble in alkali. Therefore, it is not soluble in alkali. Last is what would happen if we take the 3 degree. So you have R, nitrogen, R, and one more R. Now, since it is not having any hydrogen, तो कौन से chlorine के साथ जाएगा? That is why no reaction. As there is no hydrogen on nitrogen atom. ठीक है, that is why यहाँ पे reaction ही नहीं होता because of the absence of hydrogen atom. All of you got this? Yes or no? Please tell me. Hensberg reagent, the working, how to distinguish, क्या क्या फर्क होता है 1 degree, 2 degree और 3 degree में? Yes or no, guys? Raise your hand once you're done. Waiting for Aisha and Rabah. Just waiting for Rabah now. Moving on. Right, the 7th, that is electrophilic. Aromatic substitution of aniline. Regarding the NH2 group that aniline has, we will write NH2 group is highly activating and ortho para directing due to strong plus M effect. Strong plus M effect. Okay. No. The first reaction that we have to study is bromination. In bromination, we'll have benzene ring attached with NH2. We are just going to use we're just going to use bromine water, Br2 aqueous, and we will get tri-substituted aniline. NH2 is as it is. All the ortho and para positions of bromine is all the ortho and para position of aniline is attached with bromine. Now, why does it give tri-substituted product? It gives tri-substituted product because of strong plus M effect. Okay. So you'll write here, aniline gives, rather I'm just writing, gives tri-substituted product on bromination. Due to strong plus M effect. Okay. Now, what if we want only a single product? Scroll up. Okay. Now see, if we want to, if we want to control it, then acetylation of aniline is done. Okay, so you write the next point. To control highly activating nature and get monosubstituted product acetylation of aniline is done. Acetylation of aniline is done. ठीक है, तो यहाँ पे आपके पास you have aniline, and we have seen the acetylation ना, उसमें हम लोग acyl chloride या फिर acetic anhydride यूज कर सकते हैं. Acetic anhydride is generally used because it can be easily made and it is readily available. So आपके पास this is your acetic anhydride, and this can be also written like this, है ना, CH3CO whole twice bonded to oxygen. What would happen? The nitrogen atom will attached, एक हाइड्रोजन निकल जाएगा, so you will have NH remaining. This will be bonded with C double bond O, further bonded with CH3. ठीक है, so acetylation is done. Let me just make a bit more space. ठीक है. Now, after this we can do bromination, है ना. यहाँ पे इसके बाद आप bromination जब करेंगे Br2, so you can see the ortho position, it is very sterically hindered. तो ortho position में यहाँ पे कुछ भी reaction नहीं होगा. You will only get a para product, that is bromine in the para position, and the acetylated amine in the first carbon atom like this, C double bond O bonded to CH3. ठीक है. अच्छा, अब दूसरी चीज ये है कि how to remove this whole thing. You just need to hydrolyze it in the presence of acid or a base. H2O in the presence of acid or a base, you will get NH2 back and Br. ठीक है. So here you are getting a monosubstituted product. ये तो हम लोग करते हैं, है ना. देखिए इसमें ना बहुत लेवल्स के क्वेश्चंस आते हैं इसी सेम टॉपिक से, जिसके आंसर्स ना काफी अलग हो सकते हैं. सबसे पहला सवाल आएगा, व्हाई इट गिव्स ट्राई सब्स्टिट्यूटेड प्रोडक्ट. देन यू विल से बिकॉज ऑफ स्ट्रॉन्ग प्लस एम इफेक्ट, दैट इज वन आंसर, और उसका एक जवाब हो गया. Then they will ask, why do we do acetylation of aniline? Then you will answer, to get monosubstituted product. That's it. क्यों करते हैं हम? To get monosubstituted product, we do the acetylation of aniline. Then they will ask, why acetylation of aniline gives monosubstituted product? उसका आंसर क्या होगा? Please see. When we do the acetylation, then this lone pair electron which was responsible for the plus M effect of aniline, this lone pair electron, it is diverted. This is showing resonance like this, and it will also be showing resonance with the carbonyl carbon. Now, because this lone pair electron, it is diverted towards the carbonyl carbon as well as the benzene ring, the plus M effect will decrease. जो strength of plus M effect का, that would decrease. And when it decreases, so you will get only single product. The other thing what happens here is the ortho position, it gets blocked because of this big acetyl group, and that is why there is no substitution taking place on the ortho group. That is another thing. लेकिन the whole 12th chemistry जो आप लोगों को हमने देखा है, that is only based on the electronic effect. तो हम लोग electronic effect को ही देख के रखेंगे. That is due to the resonance shown by the amide group, वहां पे क्या हो जाता है, the strength of lone pair of hydrogen atom, it decreases and it is not as activating as it was before. So what happens after acetylation? You'll write here with me. After acetylation, the lone pair of nitrogen atom interacts with carbonyl CO due to resonance, and hence makes lone pair electron less available for benzene. This decreases the activating nature leading to formation of monosubstituted product. Okay. So after acetylation, we have something like this, that is benzene ring, nitrogen atom, which is having one hydrogen. It is having C double bond O, CH3. Now, this whole thing, it is in resonance with the carbonyl carbon, making it EH bonded to nitrogen with one hydrogen, doubly bonded with carbon, and this oxygen is having a negative charge. Hydrogen will be having positive charge, CH3 is as it is. Okay. Now, because it is showing resonance there, this lone pair we can write less available for benzene. Yes, fine. I can scroll up, no problem. I'm lowering all of your hands. Please raise your hand once you are done. Waiting for Aisha and Rabah. Okay, everyone is done. Right, the next section. B part is nitration. Nitration. So when you react aniline with concentrated HNO3 and concentrated H2SO4, then you would get NH2. In the para position, you will get NO2, plus you will get NH2. In the ortho position, you will get NO2 as expected, but you get a unexpected product that is meta substituted NO2 also. NH2, and in the meta position you will have NO2. ठीक है. अब यहाँ पे जो आपके पास para position वाला, that is 51%. This is only 2%, the ortho substituted, and the meta substituted, it is 47%. So it is not a very small amount. It's not a very meager amount. It's quite, I can say that it needs some reason why we are getting 47% of meta substituted NO2. Since NH2 is a strong electron donating group, it should not give a meta product. Now, why it is giving? So you'll write the answer, write it as a point in presence of concentrated acid, the NH2 of aniline gets protonated and becomes NH3 positive. And as it is having a positive charge on the key atom, that is benzene just atom se juda hua, it is having a positive charge. So it will be now what? It will be now deactivating and beta directing. So let NH3 positive, which is deactivating and meta directing. Hence, nitration of aniline gives significant amount of meta substituted product. Right, next, to get mono substituted product, mono substituted single product, PRO product acetylation is done. ठीक है, पहले इन दो पॉइंट्स पे लिख लीजिए, देन वी विल राइट की एसिटाइलेशन कैसे होता है. Raise your hand once you're done. Just waiting for Rabba now. Okay. Rabba is also done. Let's see sulfonation. I don't know how what is the reaction to get monosubstituted product ना. तो यहाँ पे सबसे पहले आप लेंगे aniline. इसका acetylation होगा. After this, we need to add HNO3 and H2SO4. That is our reagent for nitration. And you will only get a para-substituted nitro product because ortho position, it is quite hindered right now. And after hydration in the presence of H plus or OH negative, you will get back the NH2 group. Nitro group will be as it is. Next reaction is sulfonation. So in sulfonation, the reagent used is concentrated H2SO4. NH2. We'll react this with concentrated H2SO4 and you will get NH3 positive and HSO4 negative. What is this? Nitrogen, it is having lone pair electron. It will attack on the hydrogen of H2SO4. It will get one hydrogen. So now nitrogen, which is having two hydrogen, it has now three hydrogens with a positive charge. And H2SO4, it has lost a hydrogen, so it becomes HSO4 negative. Now, if you heat this, there's a reaction which takes place between the protonated anilinium ion. This is protonated anilinium ion. And the temperature is approximately 453 to 473 Kelvin. 180 से 200 डिग्री सेल्सियस के करीब रहता है. And you get a para substituted sulfonilic acid. मतलब SO3H group, it is attached on the para position. NH2 is as it is, and you will get SO3H. Now this SO3H, the hydrogen of this sulfonilic acid, this sulfonic acid, it is also acidic. The hydrogen kya hoga? It will be abstracted by nitrogen atom, and you will get something like this. benzene ring, NH3 positive, and here you will have SO3 negative. Okay, so compound which has a positive as well as a negative charge, सेम कंपाउंड के अंदर ही, सेम मॉलिक्यूल, एक ही मॉलिक्यूल के अंदर, तो इसको ज्विटर आयन बोलते हैं. ज्विटर आयन फॉर्म होता है, दिस नॉट नेम ऑफ अ कंपाउंड बट इट इज रादर अ प्रॉपर्टी, है ना, ज्विटर आयन. ज्विटर आयन आप लोगों ने देखा होगा बायोमोलिक्यूल्स में भी. इन बायोमोलिक्यूल्स आल्सो वी हैव ना, कि जहां पे आपके पास दी अमीन NH3 पॉजिटिव हो जाता है और कार्बोक्सिलिक एसिड COO नेगेटिव. तो मॉलिक्यूल इट इज हैविंग पॉजिटिव एज वेल एज नेगेटिव चार्ज, तो उस तरह के मॉलिक्यूल को ज्विटर आयन बोलते हैं. द नेम ऑफ दिस कंपाउंड इज सल्फानिलिक एसिड. सल्फानिलिक एसिड. ठीक है, please copy this down. Now there is a small note that we have to write, that aniline it does not show Friedel-Crafts reaction, and why it does not show. So please write a note. Aniline does not show Friedel-Crafts reaction due to the formation of salt with Lewis acid AlCl3. Due to this, the nitrogen gains positive charge and acts as strong deactivating group. Acts as strong deactivating group. Hence, do not react further. आपके पास है aniline which looks benzene ring that is having a NH2 group. When you add here AlCl3, you will get nitrogen with 2 hydrogen and a positive charge, and AlCl will get the coordinate bond and it will get also the negative charge. ठीक है, so nitrogen atom is giving electron density to aluminium atom, that is why it is getting negative charge. But since this nitrogen atom is having a positive charge, it cannot really react further on to show Friedel-Crafts alkylation or Friedel-Crafts acylation, both of these reactions. Please copy this down. I am lowering your hand. Please raise your hand once you're done. Waiting for Aisha and Mariam Parker.